So once again, section 1.6, pre-calc, brand new stuff, but not really. So you're going to be expected to understand how to simplify these rational expressions that are a little bit challenging. My nickname I give it is factor, factor, hactor, hactor. So for example, these x squared, students are going to want to cancel. But remember, if I have 10 minus 2 all over 10 whatever plus 8, and I did the math, I'd get 8 over 18, which is 4/9. But if I just cancel these out, I'd get negative 1/4, which is not the same. So when can you cancel these out? If they're connected by multiplication. See, then, if I did the math, I'd have 20 over 80, which reduces to 1/4. But if I just canceled the tens out, then I'd have 2/8, which is 1/4. So if these are connected by multiplication, you can factor. That's why you have to factor, factor, then hactor, hactor. So what is this thing? It's a difference of two squares. So that's x minus 2, x plus 2. This is just your good old standard trinomial. So we're going to factor that. X, two factors of 12 that add up to 8. We're going to go with 6 and 2. Notice the binomials are connected by multiplication. Binomials are connected by multiplication. These cancel, so x minus 2 all over x plus 6. And again, you're going to be tempted to cancel these x's out, but you can't, because same reason we couldn't cancel the tens out when it was plus. So you're done. Or you can just look at it like this. These two things are not the same. So you're done. This one, adding complex fractions. Well, when you have fractions, 1/7 plus 1/7, that's 2/7 because you got common denominators. That's the key. Right here, we do not have common denominators, but if we look at this as x3 over x plus 1, we're like, aha, this is going to be my new common denominator. I'm going to multiply this by x plus 1. I'm going to multiply this by x plus 1. And so if I distribute this, I'd get 5x plus 5 all over x plus 1 plus 3 all over x plus 1. So now I have common denominators. Notice the denominator doesn't change. 1/7 plus 1/7 is 2/7. Denominator doesn't change. So I'm going to add the I'm going to add the numerators, find like terms. 3 plus 5 is 8. So I get 5x plus 8 all over x plus 1. And you would be done. Okay, last little chunk of section 1.6. So they give you a function, and you see this is actually y equals 2x squared. So we would say our input would be our x's, and then our output would be our y's. So if we know what x is, we can plug it in here and find y. So this is a kind of a matter of just logic and knowing what you have and what you can find. So if the input is -6, so they're saying let x be -6. What is the output? That's saying find y. Pretty simple math, but do you understand the instructions? So here we go. We're just going to put -6 in right here. So we get 2 times -6. I'll just put it like this, -6 squared. 2 times 36, and that'd be 72. Now what did you find? You found 72. What does it equal? Y. What does that equal? F of x. So that is your output. Our input was -6. Now they're going to come at you a little different. See if I got space over here. Barely got enough space. If they're saying the output is 16, what is the input? So they're saying let y, which is the same thing as f of x, equals 16, and find x. So we go, okay, 16 equals 2x squared. And now we're going to divide by 2, divide by 2. We get 8 equals x squared. Now something I teach, especially in Algebra 2 class, bada boom, bada bang, do the right thing. Because if I have 49 equals x squared, and we're trying to find all the x's possible, you know the answers are plus or minus 7. That's why bada boom, bada bang, do the right thing forces us to remember there's going to be a plus and a minus. That's why this pops up. And this turns into the square root of 4 and the square root of 2 with a plus or minus in front there. So I get plus or minus 2 square root of 2. There, that's my input. All right. Now they come at you even differently. What is the equation for determining the input from a given output? So it's kind of like, all right, let's build an equation to show what it is we just did. So what we need to do is take a look at this, the original problem, y equals 2x squared, and we need to solve for x. So we're going to get x equals some stuff that actually has y's in it, so that if we were given the value of y, we could just put it in here and quickly find x. So we're just going to divide by 2, divide by 2. I'm going to turn this around. So I get x squared equals y over 2. Now I'm going to go bada boom, bada bang, do the right thing. So I get x is plus or minus the square root of y all over the square root of 2. And I think they probably want us to get that square root out of the denominator. I'm not sure. But then we're going to get plus or minus the square root of 2y all over 2. So this is a mess, I know, but my answer would be x equals plus or minus the square root of 2y all over 2. Now they might have you stop right here. I'm not sure, but something tells me they're going to have you get the radical out of the denominator, which you're going to learn about that more and more and more. So that's it for section 1-6. Good luck on that homework.